Okay, so in this case, we've got oxygen reacting with a given organic compound contains carbon, hydrogen, oxygen. But I'm not going to specify what it is. It could be a few different things. But in any case, there's an organic compound which reacts with oxygen. Okay, so is a combustion reaction. And we're asked to calculate the volume occupied by the CO2 produced from this reaction. Right, so how am I going to go about working that out? Well, in order to work out the volume occupied, we're going to need to get the actual the number of moles of carbon dioxide. Right, the question tells us 1 mole of any gas occupies a volume of 24 decimeters cubed at room temperature and pressure, and we're told that we want to know how much volume would be occupied at room temperature and pressure. So we need to work out the moles of carbon dioxide, right? And that's not given in the question. But what we are given is the grams of oxygen, right? And we're also told that C₂H₆O is an excess, right? And in this case, we are actually assuming that all the combustion which did take place, the reaction that did take place, was complete combustion, right? So all of the oxygen which reacts to form the products, including the carbon dioxide. And what we're going to do in this case is we need to work out the moles of oxygen that reacts, because by using the balance equation which we have, we can work out, well, how much carbon dioxide was produced. So let's do that. So for oxygen, we're going to need to use the equation that the mass is equal to the number of moles times molar mass, right? So if we rearrange this, it's going to be, by dividing both sides by the molar mass, we're going to get the number of moles is equal to the mass divided by the molar mass. And in this case, we're looking at the number of moles of, first of all, oxygen, right? So number of moles of oxygen, O2, molecular oxygen, is going to be the mass, right, which is 9.97. And that's going to need to be divided by the molar mass of O2. So we need to work out the molar mass of O2 to kind of go through this process. If you refer to the periodic table, you can see oxygen here. So that's going to be, so the MR of O2 is going to be the relative atomic mass 16 of oxygen multiplied by the frequency of occurrence in the molecule, which is times 2, right? So you work that out, you find that that's going to be 32, right? 32, and that's going to be in grams per mole, right? Okay, so we've got now 32 as the MR of O2. So you can plug that in here, so 32. And that's going to give us the number of moles of O2. So if you work that out, what you should find you get is 0.311 5625, okay? And that's going to be in moles, so mole. Okay, so now, as I said, our main target is actually working out the number of moles of carbon dioxide, right? We've got the balance equation here, so using that, we can work out, well, with a ratio, so the ratio between the number of moles of oxygen compared to the number of moles of carbon dioxide, right? We've got a coefficient next to the oxygen of 3, so we're going to put a 3 here, and we're going to put, for carbon dioxide is a 2, so we're going to put a 2 here. What does this mean? Well, this means for every 3 moles of oxygen, O2, that we have, it's going to produce 2 moles of CO2. Now, if we get the left-hand side to 1, right, and the way we can do that is by dividing both sides by 3, we're going to get 1 on this side, and on this side, we're going to have 2 over 3, okay? And what does this tell us? Well, this tells us that for every 1 mole of oxygen, O2, we get 2 over 3 moles of carbon dioxide. So therefore, the moles of carbon dioxide, not CO, would not be carbon dioxide, CO2, is equal to 2 over 3 multiplied by the number of moles of oxygen. And we have the number of moles of oxygen, we just worked that out. So simply put, we can do, therefore that equals 2 over 3 multiplied by 0.3115625, right? And if you work on now well, if we work that out, you're gonna get 0.207, right? 708, and I'm not going to put many decimals beyond this because you're going to get you would have a lot of threes, but I'm going to leave it at that, which is like about 7 decimal places for now. But that's going to be in moles, right? So this is our number of moles of carbon dioxide, right? And as we were told in the question, 1 mole of a given gas at room temperature and pressure is going to occupy a volume of 24 decimeters cubed. So in our case, if we multiply the value of moles for carbon dioxide that we got by 24, we're going to be able to work out the volume, right? So in this case, it's going to simply be, therefore, the volume, right, of CO2 is going to be equal to 2/3 multiplied by the 0.2077083. Okay, and that's simply going to give us no, it's not going to be 0. It's going to give us 4.98 and 49992, right? And that's going to be in decimeters cubed, right? Now we've got a volume value for our CO2 now, but we need to remember what we've been asked to do. We've been asked to give our answer to a maximum of 2 decimal places, right? So this isn't quite what we can say, well, this is your answer, because it doesn't adhere to that particular requirement. So if we now round this is going to be therefore equal to 4.9, and in this case we've got 4 here, so we can just round it down, right? So 4.98, right? That's going to be in decimeters cubed, and that's going to be to 2 decimal places, right? Okay, so in this case, our volume for the carbon dioxide is 4.98 decimeters cubed. Yep.